Welcome to this MPI presentation on object and scene description. This is part of a series of 8 presentations that MPI is organizing to introduce 5 standards that are reaching the final approval stage and 3 call for technologies that signal the beginning of 3 new projects. MPI. Who is MPI? It's moving picture, audio, and data coding by artificial intelligence. It is an international, unaffiliated, not-for-profit standard developing organization. We develop AI-based data coding standards, and most importantly, we strive to attach clear intellectual property right licensing frameworks. What is the organization? So we have a general assembly, we have board of directors, but what is important for today is that we have development committees that develop standards, and we have other groups here that are working for future new standards. What is the process that we use to develop a standard? So anybody can come and propose a new standard. We try to understand in which cases this proposal can be used. Then we define the functional requirements, the commercial requirements. When both are available, we call for technologies. We obtain the technology necessary to develop the standard. And when the standard is ready for approval, we publish it requesting community comments. And this is exactly what we are doing today. MPI standards have some particular features. With our coding standard, we try to make explicit the computing workflow of AI applications. And an MPI standard breaks up applications, AI application, typically monolithic, into a set of smaller interacting components that exchange data of known semantics, known as far as possible, of course. Then developers of solution can offer standard component that have an improved performance. And humans can select applications and they know somehow the internal operation of these applications. So this figure represents our approach to AI standardization component-based. And in this approach, an AI application is subdivided in smaller components, AI modules, aggregated in one or more AI workflows, and executed in a standard environment. All this is contained in the one foundational technical specification called AI framework. So this is the reference model. You see here that we have AI modules with input data, output data, and we said that these have known semantics. The function of the AI module is also specified. The modules are interconnected and create a workflow, and the workflow is executed inside this environment, and the controller has the possibility to call APIs for communication, storage, access, and also to the MPI store, which is where the AI modules and the AI workflows are stored and can be downloaded. It can also call security APIs for communication, encryption, and attestation. Every standard creates an ecosystem, and MPI has many standards already. We have standards, we have developers, we have integrators, we have consumers. And in order to cope with the challenges of this new technology called artificial intelligence, MPI has established a not-for-profit organization called the MPI Store, whose role is to guarantee that the components, AI modules, and AI workflows are interoperable, trusted, and available. This is contained in the system technical specification called Governance of the MPI Ecosystem. I said MPI Ecosystem. Let's see what it is. So this is MPI producing standards. A standard is taken up by an implementer. Then MPAI appoints performance assessors. Performance assessors have the task of assessing how good an implementation is, how good is the performance of that implementation. So the implementer submits an implementation to the performance assessor, assuming that the answer is positive. Then let's see what happens with the MPI store, whose role is to verify security, to test conformance, check performance, and then the performance is not actually carried out by the MPI store, but is information that it receives from performance assessors. The implementer submits an implementation to the MPI store that does the necessary checks, and if everything is okay, then the implementation is posted, is made available on the MPI store. So an end user can download an implementation, use the implementation, and provide feedbacks about their experience. We have done more than these two standards. We have a standard on context-based audio enhancement, compression understanding of financial data, multimodal conversation, neural network watermarking, and two technical reports, the MPI Metaverse model, functionalities, and another one on functionality profiles. On this time, we have published 5 standards for community comments, and we expect that it will become standards on the 29th of September of this year. So these are the standards. One is the version 2 of AI framework, and another one is the version 2 of multimodal conversation for human-machine conversation. And new MPI standards have been approved, and we intended to publish them as standards at the end of September. Avatar representation animation, connected autonomous vehicles architecture, and MPI Metaverse model architecture. But we have more brewing in the pot. We have 3 call for technologies. One is artificial intelligence for health. The presentation will be tomorrow. Another one is the object and scene description, which is what I am presenting now. And another one is extended reality venues that will be presented on Tuesday. But we have more opportunities that are being explored on video coding end-to-end based end-to-end video coding, and AI enhanced video coding. And also we have a project being worked out on online gaming. Good to mention the fact that IEEE has adopted without modification 4 technical specifications as IEEE standards. The AI framework, the audio one, the multimodal conversation, and the financial one. And we have a 5th one on neural network watermarking that is on its way. I'm proud to say that all this has been achieved in less than 3 years. So let me now go to present the specific part, object, and scene description. So I said that this is a call for technologies, in the sense that this is a project. We don't have any standards. We want to develop a standard, and according to our process, we are calling for technologies. And we wanted to obtain a technology that supports some of, preferably all, the functional requirements of a document that is called use cases and functional requirements, which identifies functional requirements for unimodal and multimodal objects and scenes. The purpose of this technical specification that we plan to develop is to specify object description and their localization in a space. The proposed technology will be used to develop the planned technical specification. If you are a proposal, then you are requested to state your availability to license your technology, if adopted by ENPI, in conformity with the framework license. I will say a few words about that. So let's see what we try to address. ENPI work on the basis of use cases in general, and we have identified quite a few that need common technologies that fit into the under the heading of object and scene description. So, for instance, we have this here. You will see the visual scene description, which is the front end, the audio scene description, which is another front end, and here you have visual objects here. You have audio objects here. How do you connect them? So we need something, and we will see in the proposal what could be the inside of this model. So then we have several other components that I'm not going to present for sake of time. So we have the human connected autonomous vehicle interaction. So here too, we have the case of having the visual scene description and the audio scene description producing objects and their geometries, and we needed to be able to correlate these two objects when we have, for instance, a person and a speech. And we need so we know the position of the speech, and we know the position of the human. We have to correlate that, and this is the purpose. Then we have the autonomous motion subsystem, which is another important point. So it receives what we call the basic environment representation, and this is something that is indeed audio and visual. It exchanges the environment representation with other connected and autonomous vehicles, and creates what we call a full environment representation that, of course, we need to give a format. So this is what I was referring to. So this is the basic environment representation. It is just the integration of different sensors that are present in a vehicle, in a connected autonomous vehicle, and this environment sensing subsystem. This is the name of the subsystem. This ESS data fusion creates the basic environment representation. Then we have another case where we have again the need to correlate audio and video objects. This is another big use case that is called avatar-based video conference, that is divided in 4 subsystems. One of them is a transmitting client. And here we have again the audio-visual alignment that I was referring to. Then we have the server. The server does also something that is relevant, because it selects the environment, the virtual environment, and also places the avatar in appropriate places. So this again is an example of applicability of this standard. And again, in the context of the avatar-based video conference, we have the receiving client. The receiving client receives the environment model, the avatar models, and their position and orientation. Based on that, it creates a visual scene creation. but it also creates a passage to the audio scene creation, what we call a spatial attitude, which is the position of the mouth of the avatar, where the audio scene creation will place an audio source with position and orientation that depends on the avatar. So let me start with a few examples of how we can define the functionalities of the many pieces that we need. So this is the visual scene description that I have referred to several times in the use cases. So we have a visual input. We don't say which type of visual inputs we have, but what we define is that the visual scene description generates a scene geometry, which describes the scene, and then it also produces the physical objects that are in the scene, and it does not produce the human objects that are in the scene, but it produces the body descriptors and the face descriptors. Because this is more convenient, and in our use cases, this is what we need. Then we have the audio input for the audio scene description, and the output is again the audio scene the geometry, but then, I mean, here we have the individual audio objects. Now let's see how we can work the audio and visual alignment. So we have the audio scene description, the visual scene description, we have the visual scene geometry, the audio scene geometry. They are passed to the audio visual alignment AI modules that creates the audio visual object identifiers. And of course, we also need the objects and the body descriptors. I have talked about spatial objects, so the objects. So imagine that we have an object in a space. This is why we call this spatial object identification. And we wanted to know what object is that. So we assume that we have a human that is using their fingers to indicate. So, and this is done with the body descriptors, the physical object of interest. We also have the visual scene geometry, so we know exactly where this body is placed, where this finger points to, and the output is coordinates. And here we have, again, by means of the visual scene geometry and the coordinates, we have the object extractions, and we can have as output the physical object, because now we know which among the many objects we are interested in. So this object identification simply gives the ID of this physical object. So we have a number of data formats that we wanted to define. We want to define the virtual environment for audio, the virtual environment for video, the coordinates, the angles, and the objects, the spatial attitude and point of view, the audio scene descriptors. This actually are already defined, but there's room for improvement, of course, and the visual scene descriptor as well. And most important, we need to define something that at the moment does not exist, which is the descriptor that combine the audio and visual components. So with this, I finish the part of my presentation that refers to the technical part, and I will say something about the framework license. So this is text that has been developed by legal experts. It is rather simple, but I think it is important that submitters are aware that we request the submitters to accept the framework license. If they don't, their submission will not be accepted. So this framework license applies to the obviously description, as it will eventually be developed and adopted by MPAI. We request that all contributors to the standard shall confirm in writing their intention to make available a license for their essential intellectual property right based on the condition of use of the license. So which are the conditions of use? So we have 3 slides. The first is that the IPR holder committed to issue a license with the following condition: will be in compliance with the general accepting principle of competition laws and the empire statutes. The license will cover all claims to essential IP and copyright of a licensor that are practiced by a licensee of the standard. So if you are a licensee, you want to be able to get all the IP that is, of course, is relevant for the standard. Then it also covers the development rights and implementation rights. Then we say that the license will grant access to essential IPRs of the standard in non-discriminatory fashion. So, of course, you cannot just grant a license to your friends and not to someone else. No, it has to be non-discriminatory. And then the scope of the license may be subject to legal bias and ethical and moral limitation. We are talking about artificial intelligence, a general clause that we have that there may be legal bias and ethical and moral limitation to the license. Then royalties will apply to a baseline profile, but also to other profiles, if there will be other profiles, to any implementation that is based on the standard, but we exclude certain types of implementation that I will introduce in a second, and of course on a worldwide basis. Then an implementation of the standard may use intellectual property rights to extend the implementation standard or to provide additional functionalities. The exemptions that I was referring here are that a license for development and implementation right, if it is developed and implemented for the purpose of evaluation and technical trials, this will be free of charge. A license may be granted for free of charge for other particular uses, and a free of charge license for a limited time and a limited amount of forfeited royalties will be granted on request. So there are certain freedom in the licensing. Then a preference will be expressed on the entities that should be administered the pool of holders of patent essential to the standard. The license will be issued before commercial implementation of the standard become available on the market. So this is one important point. You have the standard, but you never know when you will get a license on it. No, you will say, you know that if someone has a license, you should also have it. And the commercial implementation implies the general availability to any users and does not include the trials. General availability is a term that is defined in the part that I did not copy to the slides. Then the total cost of license, which is another essential element, issued by IP holders will be in line with the total cost of the licenses for similar technologies standardized in the context of standard development organization. The total cost of the licenses, finally, will take into account the value on the market of the standard essential IPR. So these are the very general conditions that submitters should accept when they make a proposal. So anybody is entitled to respond to this call for technologies. The response is to reach the Secretariat at this address by the 2023 in November, the 20th of November. And there are 4 documents that you should become aware of, which is the text of the call for technologies, the use cases and functional requirements, the framework license, and for your benefit, there is a template that you may like to use, but we strongly encourage you to use in your responses. So with this, I look forward to working with you on this exciting MPI project. And the way to do it is by joining MPAI, share the fun, and build the future. Thank you for your attention.